going to do something a little unusual. Usually I have a presentation ready, but my presentation today is what Dave Bass gave me, so I'm going to read a lot of it. So to start out, I am David Bass Jr. Thank you. I began my employment with the Texas Highway Department as a summer help in 1952, working as a survey party rodman. And I retired in 1993 as the Fort Worth District Material Engineer. And I would like to take you back to those good old days of yesteryear. I actually missed the conflict in Korea by a few days in the early 50s, but I did serve in the Army Reserve as in the Corps of Engineers, finally retiring there at the rank of colonel. Most of my time was spent as a student and or teaching. Coming into TxDOT, my first assignment was basically as a construction inspector on a freeway project, and I was placed under the direction of a chief inspector. There I learned that the main testing instrument was a shovel. Now think about a shovel. What can you do testing in the highway department? Well, first of all, we lean on them, right? And that's standard. When we have a meeting on the road, we have to lean on a shovel. Extremely important. But you could use it for checking the density of soil. You could also use it in concrete. So basically, when you make a beam, and most of the young people don't know what a beam is, but we use those a lot, you could use that to shovel the concrete into the beam. Of course, you had to rod it, so you turn it over and use the handle to rod it, used in 2 lifts, and then you have to tap it, right? You have to tap the sides to get out the air, bang it with a shovel on the side. Multi-purpose tool, works great. Then we would actually take some kind of a device and scratch information on the top of the concrete, usually where it was made, the date, etc. Put our handprint in. No, we wouldn't do that. But then we'd leave it out there for 7 days, and then we'd take it back and use a water beam breaker. Now, I haven't seen the water beam breaker. That must be pretty old. But we also used it to help run slump. Once again, you could rod it for the slump cone. And then you could always throw it in the back of your truck, and you had it for the next testing, or throw sand under it when you're in the ice. I don't know. Anyway, then after construction, I left and went to design, and I was in design for about 8 years. And I was working on preparing geometrics and for the district office. The manager of that department furnished the boilerplate, which contained the specifications for these plans. And then in 1972, I was assigned to the district laboratory. For the first time, I had a copy of the Green Book. Has anybody seen this before? This is the actual copy out of my office. Dave kept this along with everyone after that, and I've continued. So we have them all from 1951 to 2014. I go back and look once in a while. It's pretty interesting. They also had the manual of test procedures that came out during this time. This is from July of 1993. This is the oldest one I could find. But during his tenure as in the laboratory, D9, which is now Material and Pavements, was very instrumental in providing new tests and instruction on the implementation of the Green Spec Book and the Manual of Test Procedures. Also, many people at that time believed that you needed to use the materials alongside the roadway for your projects. And we still do that to some degree today. I'll let Darren talk more about that. One of the biggest things Dave wanted to say was the quality control materials came about during this time. So for aggregates, on the flexible base, and what's interesting is crushed toilets, and I've heard about that recently, use the wet ball mill. For crushed concrete, you would use the polish value, and for stripping of the aggregates, they didn't do anything until one of the cheap asphalt bases came apart, and then they ended up making a new test and called it the Boyle test. For asphalts, D9 at the time, Material and Pavements, stepped up to do more intense quality control. Additives were successfully being used, and everybody has a better idea. For concrete, making and breaking beams using a beam breaker. And Dave was very fond of this one method that he used with one of his resident engineers. When the resident engineer would come out, he and another guy would go outside, and they have a beam laying there they hadn't broken. They go out with a sledgehammer, and Dave would take the sledgehammer and pound it on top of the concrete, stand up and he'd yell, 553. The other guy was out there taking the number down for notes, and that was their compressive or their flexural strength on that beam. So very ingenious methods out there. The quality of finds was important. They were looking at the longevity for skid resistance. And Dave was always very big on hot mix. He said a number of new tests came out to define the hot mix aggregates. There was a good deal more attention being paid to proper design of mixes, as well as new mixes coming out, such as plant mix seal coat, stone matrix asphalt, and then of course you usually come back to the tried and the true. Lightweight aggregate came into play during this time, but most people didn't like it because it was difficult to use. And then my favorite, latex. He actually brought latex into the district, and very successful in using that, where our roads lasted up to 25 years with little to no maintenance. Also, he was looking at compaction control, skid resistance, and understanding the reasons, or helping people understand the reasons for not using diesel in truck beds, because it would strip the hot mix. And then in soils, he was looking at the different ways of doing densities. On some of his journeys, he asked one new lab engineer one time how long he expected a new hot mix overlay to last. And the answer was, we expect our mix to last 1 year. And he was like flabbergasted, but they were very honest and truthful and believing in that. So he went, the next day he asked the construction engineer. Construction engineer had talked to the lab engineer, and they said, no, we actually expect it to last 2 years. It's like, that's still not long enough, but that's what they believed, so hopefully they've been corrected since then. He says, wow, have things changed? We're now testing soil densities with water volume devices and nuclear gauges. We're properly making, curing, and breaking concrete cylinders and beams, and laboratory as well as field personnel are becoming trained and certified to perform the material tests. In closing, I would like to speak to training and communication. He said, D9 was always very helpful to us in the district in training our trainers. In the good old days, they sponsored annual lab meetings where new and old ideas were discussed, and between him and the lab engineer in Dallas, they had very, very lively discussions. They were always trying to understand why they were making the changes. And then there would be some sort of mechanism for them to learn from other state material engineers around the country. In traveling after his retirement, he had the chance to visit several, and in one stop in Illinois, he discovered they had been using plant mix seal coat for 40 years, or since the 40s, I'm sorry, and they had just discovered it here in Fort Worth in the 70s and 80s. He was wondering, why did it take us so long to find it here in TxDOT? Also, his final recommendations are that you should have schooling. Get as much education, as much information that you can. Return to the practice of a yearly lab meeting. And also did mention Paul Krugler, who's in here in the audience, is very helpful with that. Bring in speakers from other states that we might learn from. And also, never let a contract for plans or construction without consulting your district materials engineer. Thank you. I'll turn it over to Darren.
Okay, I haven't been here since 1952, so I can't use those examples. But what I wanted to do is to talk about some of the stuff that has changed throughout the last 40 years. And so I haven't been here 40 years yet either, but I do have the 1972 specification book that was in use when I first started as a summer employee in 1977. So I started looking at the specification book then and now and to try to point out some of those things that have changed. So I'm going to talk about hot mix and asphalt binder, concrete, cement, aggregates, and steel, and then some other materials, and then some construction methods using materials, and then some of the technology changes in terms of the way we test stuff. So just to start off with asphalt hot mix, in 1972 and actually in 1982, the specification book had essentially one type of hot mix. It was the item 340 dense graded hot mix, which was a method specification, where TxDOT did the design, TxDOT told the contractor how much asphalt to use. We have changed since then. So in the 2014 specification, we have a lot more different kinds of hot mix. We have very close to that same item 340, that's still item 340. We also have item 341, and that's a QCQA, and actually, item 340 has a lot of QCQA aspects to it too. Item 342, permeable friction course. So Richard talked about, plant mix seal, permeable friction course, very similar materials. That's a standard material. Item 344, super pave. This was an outcropping of the SHARP research program. 346, SMA. 347, thin overlay mixtures. And 348, thin bond friction courses. So you can see we've got a lot more types of mixtures for a lot more types of uses than we used to have. Part of that is that we've got a lot more different scenarios than we had 40 years ago or more. But we have developed new types of mixtures to address new problems. So hot mix testing. If there are anybody that remembers in the 1972 and 1982, doing a hot mix design used the Texas gyratory compactor. Those are still around, but not used so much. The Veeam stabilometer. And right now, I believe the Veeam stabilometer is still used for hot mix cold laid material, but that is it. If you wanted to take the material apart, you dissolved the asphalt out with a centrifuge solvent extractor. Now we use some other equipment. We use a super pave compactor. We test for rutting with a Hamburg wheel test. In most cases, if we're not interested in getting the asphalt back and checking the quality, we're just going to burn the asphalt off. It's faster, no solvents, a lot more easy on the technician. We also look at the overlay tester. That's coming into use now for cracking resistance and indirect tensile tests. So, there's a lot more testing available to us now than we used to have. So this is some of the hot mix components and some of the design procedures used. So I'm going to go through a few just to show you, a nostalgic look back at some of the stuff. I say look back because we haven't ditched anything. We still have all this stuff. And so we never get rid of something. We always just add to it. So the Texas gyratory compactor, that was then, but it's also used now. Then was the Veeam stabilometer. The one that we used when I started was significantly different looking. It was way bigger than this, and it didn't have a computer attached to it. And solvent extraction. I performed many solvent extractions, and I probably have some messed up brain cells because of the solvent fumes that I was exposed to. But now we got the super pave gyratory compactor, the Hamburg wheel test, and this is a different picture of the Hamburg wheel test, including the blue and gray one, which that's the newest model, and to me it looks more like a space pod or something than a Hamburg wheel test, but that's it. Asphalt ignition oven, and if you're in this industry today, you know these things, you've seen them, you've used them. The overlay tester. We expect probably more use of the overlay tester and indirect tensile strength. So just a few tidbits. Back in 2014, we tested enough asphalt and chip seal rock to pave a 2-lane road from Austin to Melbourne, Australia. That's a lot of material. That's assuming you pave over the ocean. So testing asphalt binders. I'm going to hit that a little bit. In 1972, 1982, we used penetration and viscosity. But now we also have penetration and viscosity. We haven't, like I said, we haven't thrown anything out. We just add to. We use the dynamic Shiriometer, bending beam rheometer, and pressure aging vessel to support our performance-graded binder specifications that are substantially more performance-based than the old viscosity and pin specifications. So here's a penetrometer. This has been probably used for 100 years. Not this particular model, but the pin test has been used for, I'm sure it was around when TxDOT was formed. It's been around for ages. And the absolute viscosity, you may not see this unless you come to our lab, but we still have specifications that use this test, and we still perform the test. But we have moved on. We have moved on to the dynamic Shiriometer. It's a glorified boot heel test. How many people have gone out to the hot mix and stood on it and kind of ground your boot. That's kind of what it does to the asphalt. I didn't have a picture of the bending beam Ometer, a pressure aging vessel, but those are the newest PG binder tests that we use. So a tidbit about asphalt. Back a year ago, we tested enough asphalt. TxDOT used enough asphalt. We tested enough asphalt to fill 350 Olympic-sized swimming pools, or float 15 battleship Texases, or provide 10 kegs of beer to 30,700 Super Bowl parties in each of the 50 states. That's a lot of asphalt. So let's move on to concrete. How has concrete changed? So if you go back to the 1972 specification, you know, I've written down here there were some different classes of concrete. You see a B, C, D, E, F, H. And there was 3 types of cement specified, 1, 2, and 3. Essentially everything used the standard black bar reinforcing steel. And there were air entraining, set retarding, and water reducing agents. I would say that there's probably not near as, you know, we have substantially more of those than we used to have. In 2014, you can look and see there's a whole lot more different types of concrete. There's a whole lot more different types of cement. And then in terms of reinforcing, we still have and predominantly use the standard black bar, but there's also epoxy-coated variations. There's stainless, there's low carbon chromium, there's dual-coated, that's like stainless clad, there's glass fiber reinforced polymer, and there's carbon fiber. And carbon fiber actually isn't in the specifications right now, but most of these are more specialty items and can be used in certain situations for certain types of uses. Right now we do have something that we didn't have, that we do have now is a coefficient of thermal expansion requirement for the aggregate for use in CRCP. And then admixtures, we had all the same admixtures, plus we have set retarding, you know, we have fibers. So we have on our MPL right now, at minimum, we have 200, and I counted them, we have 280 plus admixtures on our material producer list. So this is, I've got this shown as then, but you know, these are mostly physical tests of cement and concrete. We still do all these. Like I said, we don't throw anything out, we just add to. And then a tidbit about concrete, in 2014 we tested cement and fly ash samples representing 2 million cubic yards of concrete, enough to half fill Cowboy Stadium. So some of the equipment we used then and actually still have and still use for the fineness of cement. We use the Blaine fineness. But now we have the ability to look at particle size on a different order of magnitude. We have a laser light scattering particle size analyzer that can give us similar information, much more technical and much more accurate. Thermal coefficient of expansion. This is something that you can't specify it if you can't measure it. So we can now measure this to a high degree of reliability. So we have found out through research, actually when I was in graduate school at UT, the current thinking was, well, a lot of the spalling in CRCP is due to the thermal coefficient of expansion, and if we could control that, we could control spalling. And now we are doing that. That was Frank McCullough's claim to fame, or one of his pet projects. This is the guts of measuring it. We also look at a lot more chemistry than we used to. This is X-ray diffraction, and we use a lot of it for looking at elemental analysis for cement and fly ash. X-ray fluorescence, this we can look at the elemental constituents and say what atoms make up this cement and fly ash and other materials like thermoplastic and steel samples and the like. Thermogravimetric Analyzer, we can use this to look at phase changes in cement components. And a scanning electron microscope. And we use this a lot for forensic analysis to see, well, okay, this concrete is cracking. Why is it cracking? What's making it crack? And we can actually do some elemental analysis on a nanoscale level with this instrument. We like to break things. So, we have servo-hydraulic tension compression machines, which we used to have back in 1972, 82, but we have a lot more capability to do fatigue tests and other things and break things that maybe you couldn't break before because you just didn't have the capacity. Other significant changes in materials: advances in sign sheeting performance and how to measure that performance, advances in structural forensics, and advances in project-level sulfate detection. So this is a then and now on sign sheeting. The bottom half you can see engineering grade and high intensity. That engineering grade was essentially the first type of sheeting. It's essentially glass beads glued on a piece of paper or glued on a plastic sheet. And then you go to high intensity, where you do things to organize this and protect the glass beads so that you can get higher reflectivity. And then, excuse me, now we use prismatic sheeting, which is essentially molded prisms in a plastic sheet that gives you much, much higher reflectivity. And so we essentially don't use the lower grades anymore. Each of these is essentially an order of magnitude change in the reflectivity of the sheeting. We also have the ability to measure that reflectivity. We have a darkroom, and the instrument is called a goniometer, and we use digital imaging to look at, illuminate the sign sheeting or anything else that's reflective, and be able to calculate how much of the light that is being used to illuminate the object is returned to the source. This is the other half of the goniometer, which is essentially a robotic sample holder that allows us to simulate any configuration and any angles that a driver would see a reflective object. Phased array acoustic analysis. This can be used for forensics or to look for cracks in welds, and this is really taking over for X-ray. It's much safer. And we have something called a Varus conductivity detector. This is an output of a research project that TTI did for TxDOT. And so most of you probably have heard of, or maybe even have experience with, sulfate heaves, and where if you have clay, if you have sulfate, if you have moisture, which we all have moisture, and you do something like lime stabilization, you get all those components and you can have sulfate reaction that creates an expansive product and will destroy your road. So with this piece of equipment, you can drag it behind by a truck or a tractor, and it measures conductivity. So higher conductivity means there's salts present in the soil, so you can map out where you might want to go take some samples and then do actual sulfate tests. Designs with high performance concrete, new methods to speed construction, precast elements, precast pavement, and what did I get now? Have I got the hook? 2 minutes? I didn't get my full minutes, but okay. So, spliced pre-stressed concrete girders, post-tension together to complete span. So we can use concrete in applications that we could not use concrete in the past. It had to be steel. Some innovations in design, and this is some erection of those. New designs, we have spliced curved concrete girders. Precast bent caps, bridge bent caps. If I can build something off-site and haul it, I can do lots of construction concurrently, put it all together, I can speed the time of construction. So in 2014, we inspected enough precast bridge beams, which if laid end to end would stretch from Austin to Houston. Changes in materials, glass beads, weathering. We used to test things manually. Glass beads, for instance. Now we use digital imaging. We can get how round they are and the size distribution in a matter of a couple of minutes. Another tidbit of materials. In 2014, we tested enough striping material to apply a continuous stripe from the North Pole to the South Pole. We have a weathering facility, a real-time weathering facility located outside our lab in Cedar Park. And we have weathering ability in machines to try to speed weathering. We have changed the soil compaction to measure effort of compaction rather than just numbers of blows. And we've tested a lot of base material. We've got other pieces of equipment, ion chromatograph. So the last slide I have is, what has changed in the last 40 years? Or have materials really changed? And the answer is, yes, they have. And they've changed for a couple of reasons. They've changed because we need new materials to address new situations. They've also changed because we have the ability to test it better. We have computers to gather information. We have sensors that the computers can gather that information from. So it's kind of a chicken and egg thing is, did the materials change or did our ability to test it and ask more of the material change? And I'd actually propose to you that that's the actual answer, that we have new situations, new needs, we need performance of materials, and now we have the ability to measure that performance so we can specify it. Thank you.